Assalamualaikum and hi. So today I will discuss KML question 2022-2023 chapter 4. Okay, so first, an atom Y has 6 valence electron. Y react with fluorine gas to form YF2 and YF6 compounds. For each compound, draw Lewis structure. Okay, first, as we can see here, okay, these are the Lewis structure, right? So before the first step we start to draw the Lewis structure, we need to calculate the total valence electron first. Okay, so we need to calculate the total valence electron first. So here we can see there's only one Y and 2 F. So 1 times 6 for the 6 valence electron, 2 times 7 because F has 7 valence electron, equal to 14 plus 6, we got 20. So we need to minus 4 for the first, the bonding here, and then we got 16, and then the 16 goes to the F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the remaining is 4. The 4 here, we put it at the central atom here. So we got 0. So this calculation same as YF6. So we just calculate here same, but the F here is 6. So we need to 6 times 7. So here we got 48 minus 12 for the 12 for the bonding here, 6 bonding here, 6 times 2, 12, so minus 12, and then we got 36, the F here, 36 goes to here, 6, so we got 36. So 36 minus 36 equal to 0. Okay, so next, predict the electron pair arrangement and the molecular geometry. So, how we want to predict the electron pair arrangement? Here I just state all the things that maybe an extra information. But here the question only asks to predict the electron pair arrangement and the molecular geometry only. So, in the real exam, we just need to state here electron pair arrangement here and the molecular geometry, only these two. Okay, so first, how we want to predict. Okay, so here back to the structure. Okay, so as you can see here, there is 2 bonding pair. So 2 bonding pair plus 2 lone pair here at the central atom, 2 bonding pair plus 2 lone pair here, we got 4 electron pair arrangement. Okay, how about YF6? YF6 here, as we can see, 1 at the central atom, we got 6, 1, 2, 3, 4, 5, 6. So 6 bonding pair plus 0 lone pairs. Here, why there's no lone pair here, right? So equal to 6 electron pair arrangement. If F2, 2 bonding pairs plus 2 lone pair here, we got 4 electron pair arrangement. So for the class, we need to know that here AB2, B stand for bonding pair and E stand for lone pair here. So AB2, E2. So the electron pair arrangement are tetrahedral and the molecular geometry is V-shaped. And for the YF6, the class is ABC here because there's no E here because E stands for lone pairs. So we know YF6 there's no lone pair. The electron pair arrangement is octahedral, and for the molecular geometry is octahedral. Okay, we move to the next question. As for the draw the molecular geometry and state the bond angle. So here we know that for the YF2, the molecular geometry is V-shaped. So you can see here the structure looks like so you can totally see here the structure looks like a V shape, right? A V shape. Okay, so we draw a V shape here and put the lone pair at the Y as a central atom. So the bond angle here are less than 109.5. Okay, move on to the YF6. We know that YF6 molecular geometry looks like octahedral. So this is the look of octahedral. And please be aware that the bond angle for octahedral have two bond angle. One is 90 degrees and the other one is 180. Okay, please be aware for octahedral bond angle. Okay, next, predict the type of hybridization of the Y atom. So as we know, the electron pair arrangement for YF2 is 4. So 4 is sp3. Okay, and for type of hybridization for YF6 is sp3d2. Why? Because because YF6 have 6 electron pair arrangement. So sp3d2. If the electron pair arrangement is 2, so the type of hybridization is sp. So these are the things that you need to remember. So yeah. Okay, next, move to this question. Okay, so first we need to read all the information given, okay, before we start to answering. So table 1 show the boiling point for several elements in third periods of periodic table. So here we have sodium, magnesium, aluminium, silicon, phosphorus, and sulfur. Okay, so first, based on the structure of the element, explain why the boiling point rises from Na to Al. Okay, so these are the points that you need to put it. Okay, first, before you start to answer, okay, so you need to recognize. So the question state from Na to Al. So here we can see Na, Mg, and Al. Okay, first and foremost, you need to state Na, Mg, and Al are metals. So in metals, the atom held together by strong metallic bond. Okay, these are the things that first and foremost you need to state. Okay, so now explain more about metallic bond. What is metallic bond? So metallic bond is an electrostatic forces between positive metal ions and C of the localized valence electron. Okay, C of the localized valence electron. Okay, so the strength of metallic bond is proportional to the number of valence electron in metallic atoms and inversely proportional to the radius of the atom. Okay, so here most of students forgot about this, inversely proportional to the radius of the atom. Okay, so bear in your mind, you need to state inversely proportional to the radius of the atom too. Okay, next, point number 4, number of valence electron. Sodium is 1, Mg is 2, and Al is 3. And here, size of Al is the smallest because we know as we across the period, the radius getting smaller, right? So aluminum is the smallest one, followed by magnesium, and sodium is the biggest one. So thus boiling point increase from sodium to aluminum. Okay, move on. Okay, here, explain why silicon has the highest boiling point. Si exists in the form of giant covalent bond, and Si has strong covalent bond holding the atoms together in 3-dimensional array. So how the looks of giant covalent bond of silicon? Okay, here you can see this is the look of giant covalent of Si. Okay, so move to the next point. Each silicon is tetrahedrally covalent bonded to 4 other Si atoms and finally form a giant covalent network. Okay, move to the next point. High energy needed to break the strong covalent bond. High energy needed. Therefore, Si has the highest boiling point. Okay, I think that's all from me. Thank you.